So let me go through the agenda for today. So Luigi is going to introduce the engineering group and industry excellence, the division that we are part of. After that, I'm going to give you guys a quick overview of the project, especially focusing on the customer background and the business challenges. After that, we're going to jump into the solution overview, so the objective and how the team designed the architecture of the solution that then we're going to present you through a few video and mock-ups. And after that, we're going to have the key takeaways, business benefit that we're planning to deliver to the customer, together with next steps, so how the solution will evolve over time with the customers. And lastly, we're going to open up for any questions that you guys may have. Very good. I will then hand it over to Luigi for the introduction.
Thank you, Matteo. So I'm sorry for that. I will bother you just a couple of minutes with the company presentation. It's in my contract, so I need to do that. Otherwise, I will give you my resume. First of all, engineering group. Engineering is a global company, headquartered in Italy. The company started more than 40 years ago, and we are in the digital transformation sector. So we help our customer in developing and getting through the journey of digitalization. Company more than 1.6 billion and more than 15,000 people. So we are pretty big in Italy, not so much for the other markets. We are 70% of our business still in Italy, but we have many other offices around the world. Engineering USA is the biggest one, more than 200 people in Chicago. And again, what we do is, again, going through advisory and technology implementation, through also managing services for our customers. I think you can skip to the next one. Matteo and I belongs to a unit that is called Industries Excellence. So as you can imagine, engineering is as a metric organization. And one of the horizontal cross competence center is called Industries Excellence, and is about everything around the digital manufacturing. So we help our customer in getting all the processes, digitalize all the processes following the life cycle of the product. So we start with the design practice. Design practice is around getting more in the PLM space or whatever is about design automation solutions, through then following the evolution of the product. Then we move to the supply and deliver. So supply and deliver is more around all the logistics stuff. So track and trace solution with SAP or with Siemens stuff. We also then go to the biggest box that is about the produce. Produce for us means the MES systems. So we are very strong competencies, more than 300 people in implementing MES solution in different for different industries. And finally, the experience one. So about how to grab all the data and how to collect all the information, and then come back in a closed loop to the design information. This is more about the IoT space. But then we decided to create a net on that is the size practice. And this is where I lead globally, and Matteo is leading the practice in the US, on about how to grab all this kind of information that all these systems create in order to help the customer in getting better decision. And this is where we talk about resilience, anti-fragility, with a lot of simulation. We do optimization, we did operational research, and we try to help customer in getting quantitative methodologies to understand how to evolve. And one of the uniqueness of our business unit is about the capability of connecting from the very high levels, so from the creating decision support system to the physical world. So it means that we have people capable with the screwdrivers in their hands to connect the machines, get the data, and connect the sensor on that. So just to give you an example, and then I will stop. We did a project a couple of years ago about creating a brain using Bonsai and AnyLogic, and then we grabbed the data and connected the entire flow. So from the brain to the actuation in the physical world. So this is about us. Matteo, you can go.
Thank you, Luigi, for the introduction. And Now we can jump into the project overview. So first, just want to quickly introduce the customer background. So we have been working with a manufacturer of power sections. So power sections are critical components that are used in drilling operation. And one of the peculiarity of this type of component is that each single piece is basically custom made, depending on customer type of operation, depth of the hole, type of terrain, different quality standard need to be met, different specification need to be met. So as you can imagine, this add a lot of variability to the production of this type of component. And another point that I want to point out is the fact that not only the product is custom made, but even the tool necessary to create those power sections are custom made. So you can imagine as the manufacturing shop floor as a job shop where the order is fairly low, but the variability is really high. So first step of the project, this is fairly typical for us in engineering industry excellence. We try to position ourselves as doctors, not medicines, meaning that we are not going to push for a specific solution right away. We really want to first understand the challenges of our customer and then identify which type of solution could be the best fit for the customer, not only based on the specific needs, but also on other factors like the maturity level, the adoption of IT solution within the customer organization. So for this specific customer that I'm presenting today, we identify two main challenges. The first one is the equipment upgrade evaluation. So currently, R&D department is looking to introduce new equipment to make sure that the quality is met, to increase efficiency and productivity. The problem is that the customer doesn't have a way to evaluate the impact of introducing a new equipment in the entire work stream. So it doesn't have an effective way to understand if the new equipment will cause any issue upstream or downstream. So all the benefits are evaluated at work cell level, and each workstation is basically treated as an island. The second challenge that we identify as in terms of priority for the customer is the production scheduling optimization. So as explained, a lot of variability, processing time, lead time vary a lot depending on the model that has currently been produced. And currently there is no way to improve and optimize the schedule. As I said, each workstation is basically an island. They try to produce as much as possible, whatever is available. So leadership understands that there is maybe a way to improve the way of how operations are currently managed, and there is room to optimize the schedule and the job sequencing optimization on a daily basis. So once the challenges were clear, we identified the solution that we think could be the best fit for this specific customer. So just to summarize here in this slide, we start off with the objective. So the solution that we need to provide to the customer is basically a really robust decision support tool that need to serve different type of stakeholder within the organization, not just technical guys or simulation experts, but up to the VP and plant manager level, to address and provide answer to challenges that have a really wide time horizon, both strategic type of challenges and more tactical and operation type of challenges. As you can see listed here, a few examples. So if you go at the VP level, plant manager level, one of the questions that they want to get answer from the solution is evaluation of how I can increase the throughput, increase revenue. I need a new plant. I need to purchase new equipment, how this is going to affect current operation. Whereas more at tactical and operational level, the industrial engineer, the production planner have more questions related how I can optimize my production plan, for instance, to react to disruption. If one specific equipment is down, which is the best course of action to restore production and make sure that, for instance, the delivery date of this specific product is not impacted so much. So having that in mind, this is how our team designed the solution from an architectural standpoint. So basically, the solution that we built is based on 3 pillars. The first one is the user interface. So the user interface allows the end user to really interact with both data and the simulation model. So through the user interface, it's going to be possible to manage the uploading of data and also visualizing, of course, the data output. It's going to be possible to configure the different scenario and also launch experiment directly from the user interface that our team create. The second pillar is the backend, so how basically data are managed. So we develop a backend that the main target is to really simplify and introduce best practice on how to manage both the data ingestion and the data visualization, and of course also the data storage, with keeping in mind, of course, performances as the main point that has been addressed with the backend. And third is the simulation model. So the simulation model, you can think of the simulation model like the brain, the core of the solution that we develop. So the simulation model will not just capture the layout and the manufacturing process logic, but will allow basically to get the answer and the result depending on the scenario that the end user will decide to run. And it's going to be possible to run both optimization and not optimization type of experiment. And of course, it's going to be the responsible to generate the KPIs and the data output that then are going to be visualized by the end user through the UI. So why this type of architecture? Which are the benefits that we identify in creating this system architecture based on the three pillars that I just described? So the first one is the usability. As I said at the beginning, the stakeholder that are going to using this type of solution are very vast. They're not going to be only technical people. So the UI will really streamline and hide all the complexity of the backend to the end user, and we really allow to easily interact both with data and the simulation model, as you guys will see in a minute when I'm going to show the video. The second point is the data management. So creating a backend that will basically manage data input and also manage all the exchange of information between the UI and the simulation model, allowed to basically introduce better process to manage both data ingestion and visualization, and also better performances. That leads to the third point, that is scalability. So even though the current solution is meant to address two main scenario or use case, how we want to call it, we start and design the solution to be really scalable. So the idea is to easily add complexity, add more data to manage more scenario and answer more questions for the customer. And why AnyLogic? So here there are a few points that I want to outline on why we think AnyLogic is the right solution to support this type of challenges. The first one is the flexibility. So AnyLogic really allow you to effectively create models that capture the customer-specific processes and different logic, and also really support very well data-driven model. And the second point is the scalability. So it's really easy with AnyLogic to have different type of deployment configuration, starting from single computer, like the solution that we're currently delivering to the customer, but then moving up to the cloud model manager when you have larger pool of users, multi-plant. This is easily achievable through AnyLogic. And then, of course, the easiness of integration with external database. That is another key component that help us out to identify AnyLogic with the right software solution for this project. Very good. So in the next section, I'm going to show you guys a quick video of the user interface. So please keep in mind this is, I will say, a prototype still. The team is actively working. We are actually in the final phase of the project, so that's why you see me and Luigi on the stage. The team is actually busy in finalizing the project. So this is fairly close to what we are going to deliver to the customer, and we'll give you guys a good idea on how the end user will interact with both data and the simulation model. So first off, there is a login page. Different user will be able to log in and basically create and run experiments. So here you see how the user can select a scenario. As you can see on the right-hand side, can select different type of analysis. different type of experiment, and scenario are going to be outlined, so it's going to be guided in the selection. Once selected, you create and save the experiment that you want to run, and here in the input definition and review is where, let's say, the magic happens. As you can see here, the end user is drag and dropping equipment all around. These are just examples, but allow you to easily modify potentially the plant layout, how current processes are managed, and all these changes are going to be reflected in the actual plant layout in the simulation model, as you can see there. And then down below, you see for each single equipment selected, you can also visualize the related data. So in this phase, the end user is possible for him to modify, if needed, the data for specific equipment, if you wish to do so. The default one are automatically uploaded from the backend, but here it's possible to overwrite and modify manually, and fairly easy through the UI, the data. You don't need to connect to the database. You don't need to use complex Excel. With few clicks, you can potentially modify and add all the parameters that you want, specific, of course, for the equipment. Once you select also the building, in this case, we just have one plant with a different shift. You configure the experiment parameter, and then you can run your simulation. So here from the UI, you can see a live simulation run from the AnyLogic model. So this is the actual model with the plant layout. And from here, the end user can actually see the model. And once, of course, the experiment is finished, it can visualize the result. So in the next, there is just an example, dummy data being used. This is an example of how data can be visualized. In this specific example, you see a lot of equipment, and we are targeting to monitor the asset utilization. You can define a target that is the red line that is around 17%, and then you can see the outcome of the experiment. So in this specific example, it seems that, some changes may need to be applied since the majority of the equipment are below the threshold. But again, dummy data have been used. Just to provide a quick example now, the end user will be able to see the result. And again, the UI will provide a lot of flexibility in creating different type of chart, bar chart, pie chart, dashboard, depending, of course, on the type of experiment. We're going to work with the customer to define the best way, an effective way to visualize the result. So to wrap up, a few key takeaways and next step. So with this specific solution that we are creating, these are the business benefits that we're expecting to provide to our customer. Of course, main target for them is to increase production performance and efficiency. So having a tool that allows to support and evaluate the impact of the introduction of a new equipment will help them out to better understand how current manufacturing process could be improved or affected by new equipment. The job sequencing optimization will allow the planner to create a new schedule much more quickly, especially if disruption, of course, is maintenance operation is taking longer than expected, a material is not available, or a machine goes down. They will be able to log into the solution, run experiment, identify the best course of action to make sure that production is restored and the delays are minimized, for instance. And that, of course, this will translate in a improved customer service. It's really important for the customer to provide job completion date with accuracy. So, of course, the customer can be provided with more accurate estimate on when to expect their final product. For the next step, you can see the roadmap. This is, again, part of what we usually do with our customer. We really try to understand how we can position our solution in a roadmap to allow them to understand how they can squeeze out more value, not just to resolve specific issue like the two that I just described, but how the solution that we provide can be evolved over time. And again, this type of roadmap is customized depending on the customer current status and challenges. So for this specific customer, phase one is the one that I just described that we are wrapping up. Phase two is to expand the logic. So the foundation of the solution already been created, meaning that it's going to be fairly easy to add additional scenario, ingest more data, tweak the UI to be able to address additional questions and run different simulation runs. And as phase 3, we envision the creation of the digital twin. So we are planning to integrate the simulation model with the real-time data, in this case coming from the shop floor. So this will allow really to allow the customer to use the simulation model in a more tactical and operational way. So the simulation model will be able to get near real-time data from manufacturing. So for the end user, it's going to be possible to react more quickly on what's really going on at the shop floor level. And the last phase, once you have the digital twin, the natural next phase for us is the AI integration. So one of the main challenges for machine learning project is to really have good quantity of data that can be used to train algorithm and AI policy. So the digital twin is really effective in creating this synthetic data that then can be used to train much more quickly and effective AI logic and policy that then can be deployed in the real world. So in this way, you can create a policy that automatically detect a disruption and possibly suggest corrective action that need to be implemented. And for all these steps, we really do think that AnyLogic is the right tool for the simulation standpoint that really can support all these phases, thanks mainly to the flexibility and the capability to really adapt to all the steps that you see depicted here, and also thanks to the flexibility, I would say that's the main point that I think AnyLogic is bringing to the table. And yep, that's pretty much everything. So I'm open for any question that you guys may have. Thank you.
Hello, my name is Jeremy. Thank you for your presentation. I was particularly interested about the user interface you guys created. It's something that I've wanted to attach to some of the work I've done. One of the reasons it hasn't happened yet is that it's not something we've done before, so we don't have the kind of resource to do it, and I'm kind of afraid that it would become a whole project on its own, and that someone at least would end up focusing on the user interface rather than the actual simulation. So did you have a way of dealing with that, or did you just have to kind of bring in someone with the expertise already? How did you deal with that?
Yeah, so the creation of a user interface, I think, was possible for us, as we described. We have different type of expertise within Engineer USA. So we have developers that are dedicated to the creation of UI, not just for simulation, but also for other type of solution like manufacturing execution system and PLM. So for us, was kind of, let's say, easy. We have in-house expertise that can be pulled to create, in this case, the user interface that I show is in Vue.js. So it was able to develop fairly quickly the user interface that, again, create a layer that simplified the interaction with both data and the simulation model.
Thank you so much. Right in the front here. So I noticed that you said this work that you described here is phase 1 and phase 2?
Yeah.
Yeah. Could you speak a little bit about the sort of difficulty of going from where you're at now to getting to a true digital twin? And because I know I've heard this term digital twin thrown around a lot, and I think that there's sort of a gap between how accurate and how precise those models are intended to reference the real world. Mm-hmm. So did you talk a couple minutes on that?
Yeah, so the step 3 that I depicted, that is one critical step, definitely, and this really depends on also the maturity level of the customer. So first off, I think that to be effective, you really have to narrow down the specific use case that you want to address. In this way, you can identify which are the IT systems that I need, which type of data I need to collect. And based on that, you need to create the integration with the simulation model, and then start to leveraging this integration to have a tool that really allows to be more, let's say, tactical and operational. But to me, it's really important to identify first the problem, which type of data, and from there you can start to build, all the steps to create this integration with the IT system and the simulation model. But to your point, even the creation of, and getting the data that you need, that could be a project by itself. So it's not an easy step.
If I can add just one bit of information. So if you remember the picture of the high-level logical architecture, we spent a lot in developing the UI, so with Vue.js, but we didn't invest much time and money in creating the backend of the solution and the data integration, because this is where the methodology came into place, because we have a straight methodology to do that, because we did different times. And so we decided to maintain this keep out, because again, by using the model manager of AnyLogic, you can avoid recreating a real backend. So again, by connecting the UI with the model manager or the private cloud, whatever you want to call it, of AnyLogic, you could immediately save a lot of time in developing your enterprise application. We did it different times and it works really well. And again, the other part that is not there yet is about which kind of data we can find. So depending on the MIS solution, depending it's SAP, digital manufacturing, or it's Siemens, whatever, you need to integrate kind of data that are different. So this is part of the discovery of the second phase of the project, by getting this type of data and connecting the data with the backend of AnyLogic and then the UI that is already present.
Thank you so much. I'm over here on the side, in the back. There were a couple of things that you said at the beginning that really stood out to me. One being the complexity of what they manufacture, and that every single thing is unique and custom for their own customer. And then the other thing that just seemed incredibly complex to me was the different users that you intended the solution to serve and their needs. So going from that strategic to very tactical level. It just sounds like a huge challenge. Was that, like, how did you think about that in the beginning of the project? Was that a turnoff to taking this work on, or was this actually part of the selling point for them, that, given how unique everything is that they make, there's really no other approach other than to do it?
I would say a mix of both, but yeah, having two challenges that are so different in terms of timeline and end user, that was definitely one of the also main reason why we decided to implement the architecture that I just described, because in this way I know that we're addressing two use cases, but they are so different that the foundation basically already been created, so the customer will gain a lot of value, and it's going to be easier, quote, to add additional logic, because basically we already have two extreme type of use case. So we decide to invest a lot in thinking about the architecture, creating the UI that took a lot of time, and really set up the solution in a way that we see that as a foundation solution that then can address basically all the problems that stay in between the two extremes that we identify as the starting point. So yes, it was the customers, let's say, good choice of problem. It put us like the two extreme, but I think the way the team designed the solution will be able to provide benefit for additional use case, and they are going to be leverage the solution for much more than just the two use case that I just described. Okay. Very good. I don't see any other hands. Thank you very much for your time and attention.